The Monty Hall problem and the limits of understanding. We humans think we are logical, but we rarely are. One example is the famous Monty Hall problem. Not the problem itself, but how it was explained by Marilyn von Savant in Parade magazine way back in the day. The problem is pretty straightforward. You are on the game show, Let's Make a Deal, and you have 3 doors to choose from. Behind one door is a car, behind the other 2 doors are 2 goats. So let's say you choose door number 3. Then Monty Hall opens up door number 1 to show you what's behind door number 1. And it's a goat. So here's the question. Given this new information, do you change your guess? The common thinking is, no, you don't. Before door number 1 was opened, you had a 1/3 chance that a car would be behind door number 3. Now there's only 2 doors left, and you're sure that a car is behind one of them and a goat is behind the other one. But the math is a bit tricky. What do we know so far? Before you had the new information, the chances of a car being behind door number 3 was 1 out of 3. But now that you know that door number 1 has a goat behind it, the chances that door number 2 has a car behind it goes up to 2 out of 3. This is not intuitive, and it's hard to understand without working through the problem a few times, but it is the right answer. Why? Because Monty Hall knew where the car was when he opened door number 1 to show a goat. So the odds actually change. Monty Hall gave you new information about the system. Now the door that you've chosen, door number 3, has the original 1/3 chance, and door number 2 actually has a 2/3 chance of having a car behind it. Another way to wrap your mind around this is to imagine that instead of 3 doors, there are 1,000,000 doors. And you choose door number 1. And then Monty Hall opens every single door except door number 2. And behind every single other door except door number 2 is a goat. Under this scenario, would you still stick to door number 1? Probably not. But here's the interesting thing. A reader of Parade magazine wrote a letter to Marilyn von Savant, who writes a column in Parade magazine, to ask about the problem. And she clearly and logically explained why it would be a good choice to change from door number 3 to door number 2 based on the new information. But what happened next was kind of shocking. She got a lot of hate mail from professors of statistics. University professors who teach statistics. Now, why did they not believe her? The Monty Hall problem is a hard problem to wrap your mind around. You have to work through it a few times before you actually get it. The event with Marilyn von Savant and Parade magazine happened back in the 80s, back before nobody had heard of the now famous Monty Hall problem. But since that time, in our modern times, it's been on a few TV shows and it's been socially proofed in many places on the internet. The solution to the problem has been socially proofed and has been backed by a lot of authority figures. In fact, it's become such a famous problem, it was the title of an episode of the Korean drama DP. But back then, in the 80s, it wasn't socially proofed. It wasn't backed by any authority figure. It was an unknown problem. And Marilyn von Savant wasn't famous. She wasn't recognized as an authority figure, even though she has one of the highest IQs ever recorded. So what does this mean? Consider this idea. One way social proof and authority works is by helping ideas get inside to our brain. Authority was demonstrated by the Milgram experiment. Social proof was demonstrated by the famous Asch conformity experiment. With social proof and authority, you can get people to believe any crazy idea you want, to do any crazy thing you want. But consider that the opposite is also true. We will be very reluctant to believe anything, even if it's been logically demonstrated, if there is no social proof and if there is no authority. Consider that it's very difficult for our brains to understand anything unless there's a certain amount of social proof and authority to back that idea up. This would explain why Nobel Prize-winning scientists have their ideas rejected for decades before they're actually accepted. Here's an interesting example. The idea of plate tectonics is taught in elementary school. No school kid has a problem with the theory. But back when Wegener introduced the idea back in 1912, when it was called continental drift, everybody rejected it. It took 50 years to get that idea accepted. How is it that an idea presented from a school teacher to kids is immediately accepted without question, but that same idea presented by a scientist to other scientists is rejected? Social proof and authority is far more important to our thinking than many people would like to admit. Rationally considering any idea outside of social proof and authority is much more difficult than anybody would like to admit. Being able to persuasively leverage social proof and authority is a fantastic skill to have, but maybe being able to think independently of social proof and authority is an equally fantastic skill to have. To learn more about how to use your brain effectively for both persuasion and independent thinking, please visit mindpersuasion.com. Check out the links below. And because we make videos almost every day, please subscribe so you can continue to learn more. Let us know what you think in the comments. Thank you for watching.